back again. This is Wi-Fi Tech Lab channel. On today's topic, we simply gonna be focusing on static and default routing protocol. Okay, what you see right now on the screen, let's start from the left hand side. So we have a local area network 1 on this side, on the left hand side, and we have the local area network 2 on the right hand side, and then we have point-to-point communication between router 1 and the router 2, and also we have another interconnection between router 3 and router 2 to R1. Okay, so let's start by actually show exactly what are the configuration that are being done so far. These are just the common configuration. So basically what I did, I already assigned the IP addresses on these devices, but I'm just gonna show you which IP addresses I've assigned to each interfaces that we're gonna be talking, and also that we're gonna be routing traffic from. Okay, let's define what exactly the subnet that we have used. What you see right now, we are using a class C IP address. As you can see, we have 192.168.1.0/24. This tells us that this is class C IP addressing, and this is of course our network ID. And then we have chose to use this default gateway, as this is the IP address that fall under this network ID. Okay, this is one of the usable IP addresses on the range of 192.168.1.0 up to 254. Okay, so 1 is actually our first usable IP address on this network. Okay, this default gateway is the IP address that we're willing to assign on fast Ethernet 0/0 on router 1. Okay, and if you look down on that interface, we have a layer 2 switch, and this layer 2 switch connects the end host devices. These are the PCs that we have used. We have 8 PCs that we're going to be using on this layer 2 switch. Okay, so we have router 1, and then we have router 2, and then we have router 3, and on our right hand side we have another network ID that we will be using for local area network 2. So which means all of these devices will be using the IP addresses that fall under this network ID of 192.168.2.0/24. Again, this is class C IP addressing, and then we have chose to use this usable IP address under this network ID as our default gateway. We will be using, or we will be assigning this IP address to this interface that is located on R2. Okay, this is gonna be our default gateway interface, and then we have also featured some PCs. These are our end host devices. They are connected to access switch. This is layer 2 switch. Again, if you pay attention on this point-to-point communication between these two routers, we have used the subnet. This is /30, so which means we're willing to only allow 2 usable IP address under this network ID. Okay, so the first usable IP address would be 20.20.20.1, and the last usable IP address, it's going to be 20.20.20.2, and our broadcasting IP address is going to be 20.20.20.3. Remember, we can never be able to assign a broadcasting IP address on any interface in this case. Okay. And then we have used this network ID on the communication between R1 and R3. Okay, this is router 3. We will just call it R3. Okay, so we will be using this network ID, and the first usable IP address under this subnet is 20.20.20.5, and the last usable IP address is 20.20.20.6. Same thing applies between R3 and R2. Okay, now what is static routing? Okay, protocol. On our last video, we have demonstrated how to configure the OSPF, which falls under the dynamic routing protocol, even though we didn't dive deeper onto how the OSPF actually calculate and decide. Let's talk about static IP addressing. Okay, suppose that we are sitting on local area network 1 and we are trying to send some traffic on local area network 2. Okay, static or any routing protocol is what would make this possible for us to send a packet across from a different subnet to another subnet. Okay, but there is something called control plane, and also there is something called a data plane. The control plane is responsible to do all of those calculations on how to actually forward, or how to actually allow the packet to pass through to another networks. Okay, all of those calculation of the routing table and whatnot, they are determined by the control plane, and then the data plane is responsible for whatever decision that is made by the control plane in order for it to be able to forward traffic. Okay, the control plane runs all of the routing protocols. All right, let's then not waste some time. Let's just dive into the configuration that we are supposed to be running on this router. Okay, so this is R1. I will try to show you exactly what IP address that we have given to fastnet 0/0. I'll just type the command interface do show interface f0/0. If I maximize this, I will be able to see that this is the interface. It's up and it's a directly connected link, and then we can see that this is the IP address that is assigned to that interface, 192.168.1.1. This is our default gateway, and then we can see that it belongs to class C IP address. Okay, so the subnet mask would be 255.255.255.0. What about the other interfaces in here? Let me just show all of them at once. I'll type the command do show IP interface brief. Okay, by typing this command, I'll be able to see the interface status. If it is down, up, is there any IP address assigned to it? So in this case, I can see that the serial 2/0 has this IP address 20.20.20.1, which is the first usable IP address of the network ID 20.20.20.0, and the serial interface 3/0. This is the last usable is this the last usable IP address on its network of 20.20.20.4, and it's up. This one, if you look closer, it says it is administratively down. So we need to run the command interface as e2/0, and then we just need to say no shut down. If I run the command again, do show IP interface brief, I'll be able to see that now the interface is just up. Okay, however, the protocol is down, so we need to double check on the other side and see if we are having the same issue or not. Config terminal, do show IP interface brief. This one will tell us exactly the interfaces that are up and down, and also the corresponding IP address to the interfaces. So we can see that this interface is up, and also it have this last usable IP address on its network ID. So also this one, it have the last usable IP address on its network ID, and this is the default gateway of this router, which is R2. Okay, now let's go back to this interface and find out even more. Let's type in the command enable config terminal. T stand for terminal. I'm just using it shortly. So I will have to run the command do show IP interface brief again in this one, and then this is exactly gonna be able to tell me the status of the interfaces. Okay, if you look close, we have the first usable IP address of this network, which is 20.20.20.4, and also this one is the first usable IP address of the network ID 20.20.20.8. Now what you notice here, there is no default gateway of the local area network, so we don't have any local area network that is here. We're just using this router, okay, is another path or another router that can be used to forward traffic to R2 from R1. Okay, now that we have shown exactly where the IP addresses are assigned, let's come again and discuss exactly what we will actually need to configure this static routing protocol. We need to type the command IP route, and then we need to specify the network ID. I'm using A, B, C, D as an example. So this, take this as it represent an octet. So the first octet, the second octet, the third octet, and the fourth octet. So suppose this is our 192, this is our 168, this is our 1, and this is actually our 0. Okay, and we would like to repeat the same thing, A, B, C, D, A, B, C, D, sorry, A, B, C, D, and then we need to specify the next hop. Okay, this is the format that we'll be using to actually configure the static IP routing. The disadvantage about the static routing is the network administrator need to be physically there to assign these IP routes entries on each and every router that actually need or that is involved with forwarding the traffic to that destination. I'm not sure if you got that. Let me start again. So the disadvantage about this, it's unlike dynamic protocols they can automatically adjust to new changes that happen within a network. Maybe if one path have some issues, they can be able to converge without failure. Okay, in this case, if there is a convergence on the network, therefore the network administrator would have to go to each and every router and update these static routing entries to each and every router on the network. Imagine now, if you have multiple sites and then you have multiple break links, and then you will have to go to each and every link and update these IP routes. Okay, so we will be using this to demonstrate that. Let's start from R1. So from R1, let's go to the global config mode to run this command. All we need to do again, we need to type in that IP route, and then we need to specify the network ID. It's the network ID, it's not the default gateway, but the network ID that we are actually trying to send the packet towards. Okay, so in this case, this route, suppose it's located in LAN 1. Okay, so we're trying to communicate with the router that is located in LAN 2, right? We will need to know the network ID of where we're trying to connect to. In that case, we already know the network ID is actually 192.168.2.0. I will have to manually come here and then say 192.168.1.0. This is the network ID that I'm trying to connect to. And because the router doesn't know which subnet mask is used on that network ID, we need to specify it and say, okay, this is the subnet mask exactly that is used by that network ID on that local area network. It's a class C subnet mask. And then how to actually get there. Now we are telling it how to actually get there. We will be using the default gateway, or we'll be using the next hop from where we are. We are on route 1. Our next hop is that one, which is this interface over here. Okay, this is our next hop. The IP address that is located here, let's just double check. It should be 20.20.20.2, but let's verify that. Do show IP interface brief. As you can see, this is actually the IP address. That is our next hop, which we have to specify on that entry that we're trying to push. So all I have to do is type in 20.20.20.2. Okay, and then say do right. Now what you really don't know is from this router I can actually be able to ping LAN 2. Let's verify that. I will type the command do ping 192.168.1.1. I'm trying to ping a default gateway of R2. As you can see, we have sent some ICMP echo request, and then we got some echo reply. All our data transmission was successful. Okay, we have successfully being able to ping that default gateway. Maybe let me just remove this static entry so that you will see the difference, that initially we were not be able to ping it. Let me just come here and remove this network entry, so it's no IP. So if I type in the command do show IP route, this actually shows me the routing table. Okay, let's do this again. no matching routes. Okay, because we have deleted this route, so there is nothing now. So let's do this again. Actually, I made a mistake in this one. Yes, I made a mistake on that one. Let's do this. Do show IP route. As you can see now, we only have directly connected interfaces. These are the flags that represent actually the routes. So C actually represent the directly connected interfaces with the administrative distance of 0. This is the static, and then this is IGRP. This is not so stubby area. We will be talking about that also in later videos. So let's try to do a ping to that interface 192.168.1.1. Okay, let's try again one more time. Okay, we can be able to ping this IP address because this is our default gateway, but let's try to ping that one, the other one. Do ping 192.168.2.1. okay, because this is the link on our router, so it's the link within the directly connected links, so we can be able to ping it. But what about this one? Because it is too far away, it's on a different network segment. Are we gonna be able to ping it? Of course, we wouldn't be able to ping it until we actually configure that IP route. As you can see, the successful rate is just 0%. So if I type in that command 192.168.2.0 with 255.255.255.0 and then specify this next hop of 20.20.20.2. Now, if I can try to do a ping toward this default gateway of 192.168.2.1, tada, you can see we can be able to ping any IP address on this network now. So suppose if we come here, let's go to the network interface card of this PC. As we can see, this computer that is located on that network ID, we can ping this one also from this router. Do ping 192.168.2.2. Of course, I can ping it. Right. Now, what is the problem? If I can try to ping from the right hand side and to the left hand side, would I be able to ping? Well, no, because this router doesn't know how to get to local area network choose default gateway. Let's prove that by typing the command do show IP route. This will tell me exactly the static entry that is on this router. Okay, because now this have it will be able to ping it. Let's just remove the static entry by typing the command no IP route 192.168.1.0 255.255.255.0 20.20.20.1. Okay, now let's run the command again. Do show IP route. As you can see, that static route has disappeared. We have removed it successfully. Now we only have these directly connected links that can be able to ping each other. Okay, now let's do a ping. Let's send those ICMP echo requests towards local area network 1's default gateway. Do ping 192.168.1.1. As you can see, we are getting a timeout session. We have lost already 60% of our packet that we sent. We have now lost 100%. So we didn't get any feedback, right? Because the packet was just dropped because the router doesn't know how to get there. There is no entry on the routing table that enable the data plane to forward traffic towards local area network 1 until we as network administrators we manually do the configuration on the router itself. So I will have to come in here and use this format IP route to this network ID of 192.168.1.0. But what is the subnet mask that is used in here? The subnet mask that is used is just class C subnet mask 1.225.255.255.0. Okay, if I press enter here, it says the command is incomplete. Why? Because we didn't specify the next hop. Our next hop from the router that we're currently running the command on is this one. This is the interface that we need to specify the IP address that is assigned to it, which is 20.20.20.20.1. Okay, let's save this configuration. Now, if I can try to do ping 192.168.1.1, I can be able to ping any device on that network. Okay, I can be able to ping any device on that network. Remember the static IP address that we have configured from this router R1 to R2. Okay, so in order for this R3 to be functional, we would need to do the same thing, run the command on this router just in case if this path fails somehow. This one would be a forwarding path. Okay, so which means now if this one get broken, this one would be able to forward traffic to LAN 1. Okay, so which means we would need to assign the static or the floating static routing on this router. Okay, to do that we just need to specify the same IP route with the network ID that we're trying to connect to, with the subnet mask and the next hop. But in this case, on our entry, we would need to configure the administrative distance. Okay, let me just do this. In that case, we will need to add some sort of administrative distance. Okay, remember the lowest administrative distance wins. That simple means that if we can actually configure the static IP addresses along with some dynamic routing protocol. Remember the ISPF uses 110, ER3IP uses 20 RIP, and also the BGP. All of those administrative, they are actually higher than the static IP address, static routing, which use the administrative distance of 1. Okay, so if we have a static amongst the dynamic routing protocol, the static would be a preferred route. Okay, we will try to prove that now after this and see which route was used to actually forward the traffic. But before we touch on to that, let's come to verify our ping and see if it's successfully on this side. So ping 192.168.2.2. As you can see, we have actually sent 4 packets, and then 4 packets were received, and then we have lost nothing. Okay, if I can try to come here and run the same ping command, ping 192.168.1.1, as you can see, we can be able to ping the other side of the network successfully. until I break this entry. If I can come here and say no, and then go back to ping in here, let's see what's gonna happen. Nothing is gonna happen. Why? Because we have broken the entry. Now let's enable it again. As you can see now, I can successfully ping the other side, the device on the other local area network on the other side. Okay, I'm just gonna remove these entries for now so that I'll be able to also do the same configuration using the default routing. Default routing is actually used on the route that is close to the internet. So let's say no IP route, or let me just do this, do show IP route. This is gonna show me the routing table. Now if I come here and do the same command, do show IP route, this is gonna show me exactly the static entry with the administrative distance of 1. It costs nothing. So let's just say no IP route towards this network ID 192.168.1.0 via this hop, which is 20.20.20.1. Okay, I forgot something. You already know what it is. It's actually the subnet mask 255.255.255.0. Now if I run the same command again, do show IP route, I'll be able to see that the static entry is removed. So now let's use the default routing. Well, let me just say on the default routing we will be using the same format, but in this case I'm just going to specify exactly that all of these should be zeros. Let's do this. So we're trying to say from any IP or from any network, from any subnet, we want to actually forward to this hop, next hop. Okay, so if we apply this route entry from here, we're just saying that from anything that's come from the local area network, we just want it to be able to go through R2's interface, which is 20.20.20.2. And the same thing applies from R2 to R1. So let's do this. Let's come here and say IP route is from any 0/0, I mean 0.0.0, from any network or from any IP from any subnet mask. We want to use 20.20.20.2 as our next hop, and then do right. Now you will find that this network entry have an asterisk on it. Let's run the command do show IP route. The difference between the two, because this is it's a gateway of the last resort. Okay, this is actually taking us to the internet. It says from any IP address, from any subnet, we just want to use, or we want to forward the traffic toward this hop. Okay, now I can be able to ping let's see if we can be able to ping on the other side. Actually no, let's try to do that. Do ping 192.168.1.2.1. actually I can be able to ping, but from this router I will not be able to ping. Why? Because this router have no default route entry to actually let this traffic know that to get there you need to via through this hop. Okay, let's verify that. Do ping 192.168.1.1. as you can see, this is just hanging. The packet is dropped 20%, 40%, 60% of the packet has been dropped because that router doesn't know the entry towards this network ID of 192.168.1.0. and let's just do this. IP route from any network, from any subnet, we want to forward the packet towards 20.20.1. Do right. Now if I come from this PC and try to initiate a ping and send some ICMP echo request, I will be able to ping the computer that is located on the other side, 192.168.1.1. as you can see, we have successfully configured the default routing protocol. Okay, we have successfully configured the default routing protocol. Now the devices on this side, they can be able to ping any devices on the other side. 2.3, let's see if we have 2.3. 2.3 is this IP address in here. Okay, I hope this is actually informative to you.